Hello, good morning, everyone of MSc first year students of Physics Department. I am Vamsi Krishna, Assistant Professor ad hoc from the Department of Physics, AKNU Rajahmundry. So today I am going to discuss about Uni Junction Transistor. We call it as UJT. Okay. So this is the Uni Junction. U stands for Uni, J stands for junction, T is the transistor. Okay, so the Uni Junction transistor has a three terminals, which has three terminals. Okay, so Uni Junction transistor is a three terminal electronic semiconductor device with only one junction. Which have only one junction. The structure looks like this. Okay, this is base B1, this is B2, E. So it is made up of P, N. So here N is the N-type semiconductor, P is the P-type semiconductor. This is N UJT. Only the one junction between P-type and N-type. So you have only one uni junction between P-type material and N-type material. So conductor because the N-type material, N-type semiconductor, N-type uni junction transistor. So in N-type uni junction transistor, you have two bases, which is base 2 and base 1. So this contact things are ohmic. So this uni junction transistor has a two bases and one emitter. So we basically consider the N-type uni junction transistor because the whole transistor, the majority of the semiconductor is N-type semiconductor. So that's why we call it as N-type uni junction transistor. So we can call this transistor as a double base diode. Why we call double base diode? Because of two bases, B1 and B2. This symbol of this the emitter, this p-type material, which is close to the base 2, then base 1. Okay, this emitter terminal, which is close to the base 2. Okay, then B1. So this the emitter terminal is usually not located closer to the base B2 than base B1. So the device is not symmetrical. So channel how the N channel UJT looks like. This let me draw this symbol. This arrow indicates the current flowing inside the. This is B2. This is B2. This arrow indicates the flow of indicates the direction of the current that is flowing inside the UJT. N channel UJT. Okay. So usually the UJT looks like this. So emitter which is always close to the base B2, this is B, emitter E, this is P type material, this is N type material. Okay, so the distance between these two emitter and the base B2 is much less than between the emitter and B1, base B1, which is higher. Okay. Understood. So let us connect which we call it as so let us connect the external voltage source to the UJT. The positive terminal is connected to the base B2 and negative terminal is connected to the base B1. Okay, so now we haven't connected any voltage source to the emitter. So the potential at the emitter will be 0 volts. So with respect to B2, this uni junction transistor is in the reverse bias condition. Why it is in the reverse bias condition? Because so when we call the forward biased, so when PN junction diode, let us take it's a P type material, this is N type material, which is connected to the positive terminal, this is connected to the negative terminal. So when the diode is when we said diode is in the forward biased, so ఎప్పుడు చెప్తాము అంటే when P junction is connected to the higher terminal, higher potential terminal, and the negative terminal, the lower potential terminal is connected to the N type material. So then we call this configuration as a forward biased configuration. So similarly here also, so here N type is connected to the, if it is reversed, means reverse bias means higher potential terminal is connected to the negative N type material and lower potential is connected to the P type material. So here N type material have higher voltage, higher potential than the potential at the emitter. So here the potential at the emitter is 0 volts, but at N type material it has, at the base B2 it has higher potential. So this configuration is in the reverse bias condition, reverse biased configuration. Okay. So as the emitter is open, that the emitter is at 0 potential, then the PN junction is in the reverse bias. So small leakage current flow momentarily from B2 to emitter, okay, due to the magnetic carriers. So now this configuration is in the reverse biased, so the width of the depletion layer will be increased. So there will be small amount of the leakage current will flow from the emitter to the base B2. From base B2 to the emitter B2. So now, so when we connect the one external voltage source to the emitter, so so how long this reverse bias condition will be this condition means reverse bias condition will be attained. కోరుకుంటుంది అంటే until this the means emitter voltage will be higher than the potential at the B2. So it has for suppose it is 2 volts. So at let us take it is the potential between the B2 and B1 is the potential difference between the B2 and B1 is the 2 volts. Okay, then this emitter should be greater than this 2 volts. Then we can say that this uni junction transistor is in the forward bias condition. Then there is a flow of current from B2 to B1. Okay, so until and unless that the emitter is less than the potential at the B2, then the current cannot flow from B2 to B1. Until and unless the potential at the emitter is less than the potential at the B2, so current cannot flow from B2 to B1. So when will current will flow? So that means the potential at the emitter should be greater than the potential at this n-type material near the B2. Okay. So when input voltage V of emitter exceeds V1, let us say is the potential difference between E emitter and base B1. This is the V1. V1 is the potential between let us say the potential difference between these B2 and B1 means we have given the 3 volts. So we have given the 3 volts power supply to this Uni junction transistor. So let us divide this whole transistor into the 3 parts. Then this part will be 1 volt. Then this between emitter and the base B2, the voltage potential difference between B2 and E will be 1 volt, and the potential difference between the emitter and the base B1 will be the 2 volts. Okay, so if the external power supply is 3 volts, if so the voltage means if the potential at the emitter will be greater than the this V1, so then the potential will be in the forward bias condition, so that whole are there in the P junction means P-type material will injected from this P-type material into the N-type material. These holes means positive charges will injected from the P-type material to the N-type material. So there are the positive charges near this. So in N-type material there will be the less amount of positive charges, there will be more amount of electrons. So there will be a attraction, there will be repulsion between these positive charges in the N-type material and whatever the holes are coming from the P-type material. There will be get a repulsion between these 2 positive charges. So this positive will be moved towards the, then there will be a flow of charge, means there will be a flow of current. So across this the voltage is less than this means at the voltage at the emitter. So the potential difference between E and B1 will be less. So resistance will be decreased between these two terminals. This is all about the Uni Junction transistor. I hope you understand. So I summarize what I said till now. So Uni Junction transistor has three terminals. So one is emitter and two terminals is base B1 and B2. And there will be you have in the Uni Junction transistor you have p-type material and n-type material, but emitter is close to the base B2. Okay. So when we connected one external source between the bases B1 and B2, when emitter is open, then it act as a reverse biased condition. So when we then there will be no flow of current between the B1 and B2 from B2 to B1. So when we connect an external source, external power supply to the at emitter, which is greater than the VBB, means potential difference between the B1 and B2, then there will be this device will act as a forward biased configuration condition. So then there will be a flow of current due to the repulsion between holes from volts, which is injecting from the p-type into the n-type, and the repulsion is coming between the holes in the n-type and whatever the electrons is coming from the p-type material. So these repulsions due to the repulsion, the positive charges will be the move towards the base B1. So this is the way the current will generate. Okay. Thank you all. So for p-type p-channel UJT looks like this. The symbol looks like this. Here current will be outside of this B2 B1. Okay. Thank you all. I hope you understand this topic. Let's meet in. Thank you.